Alright, so this is going to be our last video lesson on nonlinear systems of equations, and today we're going to focus on equations that involve logarithmic and exponential functions. So let's start with our first example. We have y equals 2 to the x and y equals 2 to the 2x minus 12. Now, since both of these equations are solved for y equals, we can just start by using substitution and just set the equations equal to each other. So 2 to the x would equal 2 to the 2x minus 12. Now, it may not look like it, but this actually is a quadratic function. So what we're going to do is we'll go ahead and we'll move everything to one side. So I'm going to bring the 2 to the 2x to this side so that I end up with 2 to the 2x, or I mean the 2 to the x to the right-hand side, minus 2 to the x minus 12 equals 0. Now the reason I want to do that is now it should look like an exponential function because 2 to the 2x, remember, is the same thing as 2 to the x squared. Because when you raise a power to another power, you multiply the exponents. So this actually kind of resembles an a squared minus a minus 12 kind of problem. So then what I can do there is just factor this as two binomials. What multiplies to give me negative 12 and adds to give me negative 1? Well, that would be a minus 4 and a plus 3. But then remember, this really wasn't an a problem, it was a 2 to the x. So really I have 2 to the x minus 4 times 2 to the x plus 3. Now I set each of those equal to 0. 2 to the x minus 4 equals 0, and 2 to the x plus 3 equals 0. Well, this is 2 to the x equals 4, and I want to know, what do I raise 2 to? What power can I raise 2 to get 4? Well, that's pretty obvious to tell that that's going to be 2. But then if I solve here, I get 2 to the x equals negative 3. So what can I raise 2 to get me a negative 3? Well, first of all, I can realize that a positive number to any power is never going to give me negative, so that part will have no solutions. So we just have that x equals 2. And now we go back and we substitute into one of these equations. And when I take, let's say, this first equation and put 2 in for x, I get y would be 2 to the second, which is 4. And now I have the ordered pair 2, 4 as my solution. Okay, in our next example, we're going to look at a problem that involves some logarithms. So this time we have y equals log base 2 of x plus 4. And y equals 2 minus log base 2 of x plus 1. So what I'm going to do again, because I have both of these equations, they're solved for y equals, I'm just going to set the two expressions equal to each other. So log base 2 of x plus 4 will equal 2 minus log base 2 of x plus 1. But I have logarithms on both sides of the equation, so I'm going to rearrange this so the logarithms are together. So I'm going to add this log to the other side so that I get log base 2 of x plus 4 plus log base 2 of x plus 1 is going to equal 2. But now I have a logarithm plus a logarithm, and if you remember, our rules for logarithms, our property said that when you have two logs being added, you can condense those back as a multiplication problem. But I need to get rid of this logarithm, so to get rid of a log base 2, I do an exponential, so I'm going to do 2 to the on both sides. And 2 to the log base 2, remember, cancels each other out. So I get x plus 4 times x plus 1 equals 2 to the second, which would be 4. Now I'm going to need to FOIL out this side of the equation and get x squared plus, if I do outer and inner, I get 1x and 4x, so that's 5x. And then last would be 4, and then equals 4. But then I'll subtract 4 from both sides because it's an exponential. I need to get everything to one side and get x squared plus 5x equals 0. But that factors by taking out a common factor of x. So now that means that x is either equal to 0 or x is equal to 5. And now I need to go back and find out what y is, so I'm going to go to this easier logarithm problem and get y is log base 2 of, if I put in 0, I would get 0 plus 4, which would be 4. Or log base 2 of 4 means 2 to the what gives me 4. So that's going to be 2. And then if I put in 5, I get log base 2 of 9. That should be negative 5, sorry. Glad we caught that. So let's make this negative 5. So actually now that won't be log base 2 of 9. It would be negative 5 plus 4 would be negative 1. And remember, you can't take the logarithm of a negative number, so that will have no solution. And so our ordered pair, that would be our solution, would be when x equals 0, y equaled 2. So there's my solution. Our next example is also going to involve logarithms, but this time we're going to have a little different property to use when we combine our logarithms. So we've got log base 16 of x plus 3 and log base 16 of x minus 1 plus a half. So again, both of these are already set equal to y, so we'll just set the two equations, or the two expressions equal. Log base 16 of x plus 3 would equal log base 16 of x minus 1 plus a half. So I want to get my two logarithms together. So I'm going to subtract this log base 16 to the other side. So log base 16 of x plus 3 minus log base 16 of x minus 1 would equal a half. But then I can combine these two logarithms with a subtraction problem as a division. So I get log base 16 of x plus 3 over x minus 1 would equal a half. But I need to get rid of the logarithm, so I'm going to go 16 to the on both sides and get x plus 3 over x minus 1. And 16 to the 1/2, remember, something to the 1/2 power is a square root, so that would be 4. So now what I'm going to do is I'll put this over 1 and let's just cross multiply and get x plus 3 equals 4x minus 4. And then I can solve that. So if I subtract an x and add a 4, I'm going to get 7 equals 3x. So x would be 7/3. But then I need to go back and substitute that in. So I'm going to go right here and get y equals log base 16 of 7/3 plus 3. But let's put that over 1. And then if we crisscross applesauce or get common denominators, I get 7 plus 9, which would be 16 over 3. But that is the same thing because it's log base 16, and then I've got a 16 as the log base 16 of 16 minus log base 16 of 3. But log base 16 of 16 is 1, and log base 16 of 3 doesn't simplify, so we'll just leave it, log base 16 of 3. So that's going to be the value I'm going to have for y. So my ordered pair was x was 7/3 and y 1 minus log base 16 of 3. In our next example, we're going to get to use the elimination method. So we're going to have 2 e to the x plus 3 e to the y equals 7, and 2 e to the x minus e to the y equals 3. So I'm going to start by multiplying the bottom equation by 3, and that way my e to the y's will be a positive 3 and a negative 3 e to the y. So keeping the first equation, 2 to e to the x plus 3 e to the y equals 7, equals, now I'm going to have 7 e to the x minus 3 e to the y equals 9. Now, if I add those two equations together, I get 8 e to the x. Those are going to cancel, equals 16. Then I can divide by 8 and get e to the x equals 2. And now we have to go back and remember that when we are solving logarithmic equations and exponential equations, that if I want to get rid of an e to the, so I have e to the x, I'll take the natural log of both sides. So then the natural log and the e cancel, and I get x is the natural log of 2. Now I have to go back and substitute that in to find y. So let's take this first equation, 2 e to the natural log of 2 plus 3 e to the y equals 7. But again, remembering that e to the natural log cancel, I get 2 times 2 plus 3 e to the y equals 7. Well, that's 4 plus 3 e to the y. Subtract the 4 and get 3 e to the y equals 3. Divide by 3, e to the y equals 1. And then I will take the natural log to get the y by itself. So the natural log of e to the y equals the natural log of 1. But then that tells me that y would equal the natural log of 1, which we're supposed to know is 0. So then y is the natural log of 0, or is 0. So my ordered pair is the natural log of 2, 0. Our next example is also going to include or involve using elimination method. So we have 2 natural log of x plus 4 natural log of y equals 14. And 3 natural log of x plus 2 natural log of y equals 3. So I'm going to multiply this bottom equation by negative 2, and that way my natural log of y's will both cancel each other out. So I'm going to have 2 natural log of x plus 4 natural log of y equals 14, and negative 6 natural log of x minus 4 natural log of y equals negative 6. So when I add these, I get negative 4 natural log of x, those cancel, equals 8. So the natural log of x is going to be negative 2. But remember, I'm trying to get x, so I'm going to have to go e to the on both sides. So x is e to the negative 2. Now we'll go back and substitute that in. So I'm going to take that first equation and have 2 natural log of x, but x is e to the negative 2, plus 4 natural log of y equals 14. But the natural log and the e are going to cancel each other out. I'm going to get 2 times negative 2, that's negative 4, plus 4 natural log of y equals 14. Add 4 to both sides and get 4 natural log of y would equal 18. So the natural log of y is going to be 18 fourths, which is 9 halves. But I have to get y by itself, so I'm going to go e to the on both sides. So y is e to the 9 halves. So then my ordered pair for my solution is e to the negative 2 for x and e to the 9 halves for y. All right, let's look at our last example problem. This is actually one of the easier ones we're going to have. We've got 7 to the 2x plus 4 equals 7 to the y minus 3. And then y minus x equals 2. Now I'm actually going to solve this one by substitution. I'm going to take this equation and solve for y, because that way I'll keep my variables positive. So if I do, I get y equals x plus 2. So then we're going to come over here and keep 7 to the 2x plus 4 equals 7. And now I'm going to put in for y x plus 2. X plus 2 minus 3. So 7 to the 2x plus 4 equals 7 to the x minus 1. And now I can just set my exponents equal to each other, since these are both 7 bases of 7. So 2x plus 4 is going to equal x minus 1. So if I subtract an x and then subtract the 4, I'm going to get x equals negative 5. But then my equation for y is y equals x plus 2. So if I put in negative 5 plus 2, I get negative 3. So my solution is negative 5, negative 3.